Hey everybody, welcome back. Thanks for watching. So today we want to do a neat little geometry problem. So it turns out that given triangle ABC with the property that a squared minus b squared over a squared plus b squared is equal to sine of a minus b over sine of a plus b, it turns out that triangle is either isosceles or a right triangle. In order to establish that, we need some tools. One we proved previously, so in the video before this. Two is a classic fact, right? The sum of the angles of any triangle is pi. And as a result, we get this by algebra. So 3 is the sine of the difference of angles formula. That's a classic. And 4 is just the law of sines. And I'm just saying that these are equal to some constant x. Okay, so let's go ahead. Let's assume this and show that this happens as a result. Okay, so assume we've got some triangle. So I'm going to say assume triangle ABC is a triangle such that a squared minus b squared over a squared plus b squared is equal to sine of a minus b over the sine of a plus b. So we're just imagining we've got some triangle where this holds. So what I want to do is work with this, and I'm going to multiply the top and the bottom by sine of a plus b. That's going to allow me to use a property that I talked about in the previous video. That was property 1. So yeah, I'm going to multiply the top and the bottom by this, because you can see the numerator will give me this. Okay, so yeah, multiplying by sine of a plus b over itself, that gives us the following. So again, this product by the previous video here in the numerator, that's sine squared of a minus sine squared of b. And the denominator, this is sine squared of a plus b. Okay, so let's just recall on the side that the measure of angle A plus the measure of angle B plus the measure of angle C is equal to pi. And so A plus B is exactly pi minus C. So that's going to allow me to replace this with pi minus C. And then I could just expand this out using the sine of the difference of angles formula. Okay, so let's go ahead and do that. Okay, so what do we have here? So the numerator is still the same, right? So we still have that sine squared of A minus the sine squared of B. And that squared just means I've got some quantity squared. And so by the sine of the difference of angles formula, I've got, looks like the sine of pi times the cosine of C minus the sine of C times, well, the cosine of pi. Okay, so just expanding the sign of the difference the following way. And let's just compute that. So we know that sine of pi is 0, right? That's the far left of the unit circle, and the y value sine is 0, so that's gone. And so cosine of pi is minus 1, so that's going to give me 0 plus sine of c, but that's squared. So sine squared of c. Okay, so it seems pretty good so far, and now we want to recall the law of sines. So yeah, let's recall the following. So we know that a over the sine of a is equal to the b over the sine of b, which is equal to c over the sine of c. And that's just some constant, let's call it x. And so what's my goal? My goal is to replace these with these little constants or constant ratios, you'll see. And basically get rid of the signs. I want to get rid of the trig functions and just get nice little ratios. So let's deal with this first to help here. And so I've got, it looks like, so a over sine of a is equal to x. And so 1 over sine of a is equal to, looks like x over a. So that means that sine of a is the reciprocal, it's a over x. But if we think about this just by sort of a symmetry of variables, we actually get the following for free if we're careful. You can work this out algebraically if you need to, if you don't see it, which is fine. So we get, so sine of b must be b over x, and then sine of c must be c over x. Okay, it's the same argument, just replace the a with b and b, or c, replace the a with c and c. So that's helpful because if I just square both sides, I get a replacement for each of these. So if I square this, this is equal to a squared over x squared. If I square this, I get a replacement for this. And so that's equal to b squared over x squared. And then down here, so if I square both sides, I get c squared over x squared. Okay, so none of these are zeros because we're assuming we're dealing with a meaningful triangle, so I don't have to worry about dividing by 0 with x. And so I'm just going to multiply the top and the bottom by x squared here to get rid of that, get rid of the complex fractions. And that gives me a squared minus b squared over c squared. So that's pretty good. Okay, so a little bit of a journey to get here, but now we can take the left side, take the right side, and hopefully solve algebraically. So going back, our left side looked like this. And again, our goal is to equate it to this simplified right side here. And we'll see what's up with that. So maybe I'll say we have so we've got a squared minus b squared over a squared plus b squared. And we said that's equal to a squared minus b squared over c squared. Okay, so to solve this, I don't want to divide both sides by this, because I want to be careful not to divide by 0. So instead, let's get everything to one side. Okay, so just subtracting to the left, I've got everything on one side equal to 0. And we're going to factor just like we would with a polynomial. So we can factor out an a squared minus b squared. That leaves me with 1 over a squared plus b squared minus 1 over c squared. And I know if the product of two things is equal to 0, then at least one of them is. So then I can say I either have this or this. Oops, this or this. Okay, well, we're talking about sides of triangles, so I don't have to worry about negatives here. So I either have a equals b, or I have the following, or I have 1 over a squared plus b squared is equal to 1 over c squared. But by cross multiplication, that gives me that c squared is equal to a squared plus b squared. So I either have that my triangle is isosceles, or it's a right triangle. So really, really neat problem.